Hello everyone. So today you're going to learn about nomenclature, which means naming compounds. So last time you learned that there are two different types of compounds, right? There's molecular compound and ionic compound. The difference is in their composition, elemental composition. So for example, in molecular compounds, you have compounds that are only composed of nonmetals. Okay, so they consist only of nonmetals, and the chemical bond that they utilize is covalent bonding, right? So it's bonding between elements. And so a lot of these molecular compounds are composed of nonmetals only, so there's a lot of different types of nonmetals that you learned in the past. There's carbon, oxygen, nitrogen, fluorine. You have the halogens, the noble gases. These are all examples of nonmetals. And so when they react to each other and form a covalent bond, you have a molecule, right? A molecular compound. So carbon dioxide is an example, water, methane, CH4, and even alcohols like ethanol. Ionic compound, on the other hand, consists of a combination of a metal and nonmetal. Okay, and so because it's composed of a cation and an anion, you have what they call an ionic bond, or an electrostatic interaction between the ions. So if you remember, metals tend to lose electrons, and so they form a positive charge known as cations, right? Whereas nonmetals, they tend to gain an electron, which gives them a negative charge, and they're called anions. So here are some examples of different types of ionic compounds. You have salts, right, like table salt, sodium chloride. You have Na, which is a metal, chlorine, which is a nonmetal. And you also have other types of salts like magnesium bromide, aluminum oxide, magnesium sulfate, so on and so forth. But our focus here in this video or in this lesson is naming ionic compounds. So we'll talk about molecular compounds in another video. In naming ionic compounds, there's actually two different types of ionic compounds. There's type I ionic and type II ionic compounds. And the difference between these two types are, again, in the types of metal that they have, or metal ion. So for example, the type I ionic compounds are composed of main group metal ions, plus of course a nonmetal, because again you have a cation and an anion. All right, metal ions are the positively charged ions, the cations, and the nonmetal ions are the anions, the negatively charged ions. And so there's a lot of different types here. The main group metals, as you've learned, are every metals except the transition metals, right? So you have group 1A metals, group 2A metals, group 3A, and so on and so forth. So lithium, sodium, potassium, magnesium, calcium, and so on and so forth. The nonmetals are your negatively charged anions, like the nitrogen with a -3 charge, or the nitride ion, oxide ion, and so on and so forth. Type II ionic compounds consist of transition metal ions, right? And you learn that these are the metals that are in the middle of the periodic table. So you have iron with a +3, it could be iron with a +2 charge, copper, titanium, manganese. These are all examples of transition metal ions. And if you remember from last lecture, that transition metals, they tend to have multiple different charges, and that's why their properties are not as predictable as the main group elements. And one of those properties that are less predictable for transition metals are their charges, their ionic charges. All right, so again, ionic compounds consist of cations and anions. So how do we name these cations? So it's actually pretty straightforward. All you have to do is name the metal followed by the word ion. So if you have, let's say, these ions right here, you have lithium with a positive charge. We call these lithium ion, sodium ion, potassium ion, magnesium ion, and aluminum ion. So because these type 1 cations only have a single charge, right? And you can easily predict them by looking at where they are in the periodic table. So if it's a group 1 element, then they tend to have a positive 1 charge. If it's a group 2 element, then they tend to have a positive 2 charge, group 3. So basically these main group elements or metal ions have charge ionic charge that matches the group number. Okay, so again, this is lithium ion, sodium ion, all the way to aluminum ion. What about anions? How do we name these anions? So it's actually a little bit different compared to cations. You can't just say oxygen ion or nitrogen ion. So what you do is you name the nonmetal, but it ends in IDE. So the suffix changes to IDE followed by the word ion, right? So an example would be, for the first one here, nitrogen with a -3 charge, that would be nitride ion. So instead of nitrogen ion, it's nitride. So it ends in IDE, and then you have the other anions here. You have phosphide ion, oxide ion, sulfide ion, fluoride, and even selenide ion, Se with a -2 charge. So how do we name these type 1 ionic compounds? Well, the easiest way to do this is to analyze the chemical formula first, right? So you can see the first one here contains calcium and chlorine, right? And so when you separate them in their ionic form, you have a calcium ion and a chloride ion, right? So calcium with a positive 2 charge, chloride ion with a -1 charge. And so all you have to do whenever you're naming these type 1 ionic compounds is to drop the word ion and combine the two names, right? So for example, here it would be calcium chloride. Okay, and you can do the same thing for the rest here. So if you would like to practice on these 5 different examples here, you can pause the video and try it out yourself. All right, so the first one here is barium fluoride. All right, so barium, so BaF2, you have barium ion and a fluoride ion, and so again, all you have to do is drop the word ion and combine the two words barium and fluoride, which becomes barium fluoride. The next one is aluminum oxide. The fourth one here, KBr, is potassium bromide. Next one is lithium nitride. And the last one is magnesium phosphide. All right, so sometimes you'll be given the chemical name, right? The name of the ionic compound, and then you would have to come up with the chemical formula based on the given name. All right, let's try some of this out. So let's say we have aluminum chloride. All right, what would be the chemical formula for this type 1 ionic compound, aluminum chloride? Well, again, analyze the name, right? It says aluminum and you have chloride. So that must mean that you have aluminum ion and a chloride ion, right? So separate them into ions first. So aluminum tends to have a positive 3 charge, and the chloride ion tends to have a -1 charge, right? And so what you can do here is a method they call crisscross method, where you're basically sort of like cross multiplying the charges, so the charges will become the subscript instead of the superscript, right? So the charges here will go down, will be cross multiplied, right? So aluminum will receive 1, and then the chlorine will receive 3 as a subscript. So this becomes Al1Cl3. Or you can just simplify this to AlCl3, because it's implied that there's 1 aluminum ion there in that chemical formula. Alright, so let's try some other examples here. Alright, so let's look at lithium oxide first. How do we come up with the chemical formula for lithium oxide? So again, you would analyze the name, right, and see if you could separate them into ions, right, a cation and anion. So a lithium ion has a positive 1 charge, right, because it's in group 1A in the periodic table. Oxide has a negative 2 charge because it's an oxygen based anion here. So you have Li plus and O2 minus. So what you can do is you can do the crisscross method. So this becomes Li2O. Okay. Now for the next 5 here, again, if you'd like to try it out yourself, please pause this video. All right, so for the next one here, we have magnesium bromide. So magnesium is in group 2A, and so it will have a positive 2 charge. Bromide ion is group 7A, so it will have a negative 1 charge. So cross them out, and you get MgBr2 for magnesium bromide. Calcium oxide, you have Ca2 plus, right, for calcium, and oxide is O2 minus. So you have Ca2 plus and O2 minus. So this one is a little bit tricky. So again, you can use the crisscross method here, and you would get Ca2O2. But based on the definition of a formula unit, which is the simplest unit for an ionic compound, you learn that it's consists of elements in their smallest whole number ratio, right? So you have here in this case it's a 1-to-1 ratio between calcium and oxygen, and so you can just simplify this into CaO. All right, and you can do the same thing for aluminum phosphide, because aluminum has a positive 3 charge, whereas the phosphide ion has a negative 3 charge. And so when you cross them out, you have Al3P3, or it can be simplified into AlP. All right. Same thing with aluminum nitride, right? So again, aluminum has a positive 3 charge, nitride ion has a negative 3 charge, and so this can be simplified into AlN. And lastly, we have strontium oxide, right? So strontium again is in the same group as calcium and magnesium in group 2, so it has a positive 2 charge, whereas oxygen, oxide ion, has a negative 2 charge. So you can simplify this into SrO. Alright, so we're done with type 1 ionic compounds. Now let's look at type 2 ionic compounds, which are compounds that consist of transition metal ions. Alright, these transition metal ions can have multiple different charges, and so if we look at these cations, how would we differentiate them? Right, let's say if we have iron 3 versus iron 2, how would we name these cations? All right, so manganese 7 plus and manganese 6 plus. You can have copper 2 plus, copper plus. So the point here is that you can have multiple different ionic charges for these transition metals, and that's why they're not as predictable as the main group elements, which only have a single ionic charge. So the last two here, lead 2 plus and lead 4 plus, Sn2 plus and Sn4 plus, these are called post-transition metal ions. Okay, so they're not technically transition metals because they're not in the middle, but they are considered post-transition metals. All right, so how do we differentiate these ions whenever we're naming them? Right. So, for example, iron 3 plus and iron 2 plus, how would we name these cations? So remember that for main group elements, all you have to do is name the metal followed by the word ion. Right. So Mg2 plus, for example, is just magnesium ion. Lithium Li plus is lithium ion. But for transition metal ions, it's a little bit different because they have different charges. So what we do is we use the system for naming them. It's called stock system, kind of like the stock market, right? Stock system. But you don't need to remember that. But in the stock system, you can differentiate these metal ions by their charge. So we use Roman numerals. So the Roman numerals will basically represent the ionic charge. So for example, Fe2 plus would be iron 2 ion, right? So you write the name of the metal ion followed by Roman numeral that represents the charge, followed by the word ion. So in this case we have iron 2 ion. The next one will be iron 3 ion, copper 2 and copper 1 ion. Okay, manganese 7 and manganese 6 ions. Okay, lead 2 and lead 3 ions, tin 2 and tin 4 ions. All right, and then the anions, which are again the non-metals, you would name them the same way, right? So if you have oxide ion or phosphide, nitride, selenide, so on and so forth. All right, so let's look at some examples here on how to come up with chemical formulas for a type II ionic compound. All right, so let's say we have iron 3 oxide, right? How would we come up with the chemical formula? So the first thing you want to do here is to again analyze the chemical formula and then see if you could separate them into ions with their proper charges, right? So iron 3, a cation with a positive 3 charge. So you have iron, which is Fe with a positive 3 charge. Oxide is basically an oxygen with a negative 2 charge. So here we have Fe3 plus and O2 minus. So to come up with the chemical formula, all you have to do is perform the crisscross method. All right, so you're cross multiplying the charges, and so the 2 goes in front of iron, and then the 3 goes in front of oxygen. So here we have Fe2O3, where the numbers are in subscripts. Right, so it's as simple as that. So let's look at all these examples here. Again, if you'd like to pause this video, if you want to do it yourself, go ahead. All right, here we have chromium 3 bromide. Again, analyze the name, right, the chemical name, and see if you could separate them into ions. So here first we have chromium 3. So the symbol for chromium is Cr. The Roman numeral 3 tells you that it has a positive 3 charge. So that's chromium 3 plus. And then you have the bromide ion, which is a halogen. It has a negative 1 charge. So Cr3 with a positive charge, Cr3 plus, and Br minus. And then you perform the crisscross method and you get CrBr3. Right, for copper 2 oxide, you do the same thing. So you have Cu2 plus and O2 minus. And when you cross them, you have Cu2O2. And you can simplify this because, again, it's a formula unit. It's supposed to be sort of similar to like empirical formula, but applied to ionic compounds. So you just simplify this into CuO. All right, for copper 1 oxide, so you have Cu1 plus and O2 minus. So when you do the crisscross, you have Cu2O. Tin 4 nitride, you have Sn with a positive 4, nitride with N negative 3. Okay. Across them, you have Sn3N4. Iron 2 oxide, you have Fe2 plus and O2 minus. And so that would be FeO, right? So instead of Fe2O2, you would simplify that into FeO. Chromium 3 nitride, same thing, Crn. Scandium phosphide. Scandium is number 21 in the periodic table. It's Sc, and with a positive 3 charge, you have phosphide with a negative 3, so you can simplify this into SCP. All right, so how do we come up with the name? So if you're given the chemical formula of the ionic compound, how do you name that compound? So let's look at these examples. Again, there's a lot of different methods that you can use to name these, but the one that I highly suggest is by using the crisscross method, but only this time you would quote unquote reverse the crisscross, right? So for Ti2O, when you reverse the crisscross, the oxygen will receive a superscript number 2, right? So reverse the crisscross, and then you have +1 for titanium, right? So you have an oxide ion and titanium ion. And because this is a type II ionic compound, you will have to use Roman numerals to represent the charge on the transition metal cation, right? So we have a titanium cation here with a positive 1 charge, so that would be titanium 1 oxide. All right, you can pause this video to try the rest. So here we have Sc2O3. You can again reverse the crisscross here, and you can see that the scandium will have a positive 3 charge, oxygen will have a negative 2 charge, which is the oxide ion, and so here we have scandium 3 oxide. Next one here, we have CrF3. Reverse the crisscross, and you have Cr with a positive 3 charge and fluoride ion with a negative 1 charge. So here we have chromium 3 fluoride. PbI4 would be lead 4 iodide. SnO2 is a little bit tricky here because when you reverse the crisscross, you don't get the correct charge for the oxygen, right? The oxygen or oxide ion should have a negative 2 charge. So when that happens, you can multiply the charge by 2 for the anion and the cation. So it would be negative 2 for oxygen and then the positive 4 for the tin ion. And so now we have tin 4 oxide. And same goes for MnO2. So you have manganese 4 oxide. Okay, and the same goes for the rest here. So we have lead 2 oxide. And this one would be nickel 2 sulfide, and the last one is titanium 4 oxide. All right, so ionic compounds, so those ionic compounds that we looked at are called binary ionic compounds, right? So you have a binary type 1, you have a binary type 2 because they only contain 2 different types of elements, right? For example, titanium 4 oxide that we just look at, TiO2. It consists of only 2 types of elements, the titanium and the oxygen. But a lot of ionic compounds actually involve polyatomic ions, okay, meaning multiple different elements. So a lot of polyatomic ions, they contain the element oxygen. So a lot of these polyatomic ions that contain oxygen are also called oxyanions. Okay, so that means they have a negative charge if it's an oxyanion, right? All right, so here are the formulas, the chemical formula of the most common polyatomic ions, and make sure that you remember the formula name and also the name of the ion. Okay, the chemical formula and the name of the ion. So here, the first one is NO3 minus, and this is called the nitrate ion. We have BrO3 minus, okay, which is called the bromate ion, carbonate ion, iodate, chlorate, sulfate, phosphate, and ammonium ion. So notice the last one here, ammonium ion, right? NH4 plus. So NH4 plus consists of non-metals, right? Yet it's a cation. So, the basic definition of ionic compound is that it consists of a metal and a non-metal, but it's not always the case. As long as an ionic compound consists of a cation and an anion, it's considered an ionic compound. So, and that's why ammonium ion is considered a cation, even though it contains only non-metals. Notice that the names of these polyatomic ions end in ATE. Okay, the reason why is because once we look at the other polyatomic ions that have one less oxygen, the suffix will change from ATE to ITE. But we'll go over that later on in this video. All right, so let's look at naming type 1 ionic first, as well as coming up with chemical formulas, and then we'll take a look at type 2 ionic compounds involving polyatomic ions. So the first one here, we have NaNO3, right? So just like what you learned in the past slides here, you would analyze the ionic compound and see if you can separate them into ions, right? A cation and anion. So one way to be able to name these or even come up with chemical formula is to be able to see the polyatomic ions as a single unit. Okay, so for example, you have NO3 in NaNO3 here. NO3 is a polyatomic ion, and it's a single unit. Right? You have a nitrogen bonded to 3 oxygens. That's a single unit with a negative charge. So you can see that this is a sodium ion and a nitrate ion. Right? Again, all you have to do is drop the word ion and combine the two words sodium and nitrate. So that would be sodium nitrate. And you can do the same thing for the other two here. So you have a potassium ion and a sulfate ion, and combining the two ions, you would get potassium sulfate. And the last one here, you have magnesium ion and a phosphate ion. Combine them together, you get magnesium phosphate. All right, what about coming up with a chemical formula? So this one is probably a little bit trickier, but once you have the name, you can always analyze it and see if you can separate them into the respective ions, right? So ammonium, the last one over here on the left-hand side, NH4 plus. So that's the ion, ammonium ion, NH4 plus. And then you have the nitrate ion, which is NO3 with a -1 charge, right? So again, to come up with the chemical formula, I highly prefer you use the crisscross method. Okay, so now you have NH4NO3. Okay, sodium sulfate. You have Na plus for sodium and SO4 2 minus for sulfate. So perform the crisscross, and you get Na2SO4. What about for magnesium phosphate? So magnesium is in group 2, so it has a positive 2 charge. Phosphate is PO4 with a negative 3 charge. Right, and so when you crisscross them, you have Mg3 PO4 2, and you would have to keep the PO4 as a single unit, okay, altogether. So you would put them in parentheses, and then the number 2 outside the parentheses to indicate that you have 2 units of PO4, the phosphate ion. All right, and the last one here, we have aluminum phosphate. So aluminum is in group 3, so we would have a positive 3 charge. Phosphate, PO4 with a negative 3 charge. So when you perform the crisscross method here, you would get Al3 PO4 3. But because, again, it's a formula unit, you would simplify this into Al PO4. All right, now let's take a look at type II ionic compounds. So again, type II ionic compounds containing polyatomic ions are called ternary ionic compounds, just like the previous one. Any ionic compounds that consist of polyatomic ions are known as ternary compounds. Okay. All right, so for type II ionic, they contain transition metals, right? And you would apply, again, what you learned in the previous slides for type II ionic compounds. So how to come up with the chemical formula from a given name. So here you have cobalt 2 nitrate. So again, you have the stock system where the charge or the Roman numeral represents the charge of the cation. So here you have a cobalt 2 positive charge, positive 2 charge. And then a nitrate, which is NO3 minus. All right, so here you can just easily use the crisscross method. So in that case, it's cobalt NO3 parentheses 2. Okay, the next one is copper 1 bromate. So again, that tells you that copper has a positive 1 charge. Bromate is BrO3 with a negative charge. Crisscross, and you get Cu BrO3. Third one here, we have chromium 2 sulfate. So that again tells you that you have a chromium with a positive 2 charge, a sulfate with a negative 3 charge, SO4. With a negative 2 charge, SO4 2 minus. Okay, and then you do the crisscross, and you get CrSO4, right? Instead of Cr2SO4 2, you would simplify that into CrSO4. Lead 2 phosphate, you have Pb2 plus and PO4 3 minus. You do the crisscross, and you get Pb3 PO4 parentheses 2. All right, what about coming up with the chemical name? Let's say we have Fe2SO4 3. All right, so whenever you're naming a type II ionic compound, you would have to, again, reverse the crisscross and make sure that the anion has the correct charge. So here, when you perform the reverse crisscross, you get Fe3 plus and SO4 2 minus. And you can see that the sulfate ion has the proper negative 2 charge, and so that must mean that Fe3 plus is the correct charge. So now that you know the charge on the metal, the transition metal, this is called iron 3 sulfate. All right, what about the second one here? We have FeSO4. Again, you can try to reverse the crisscross and see if you get the proper ionic charge for the sulfate ion, but if not, then you multiply it by a factor to get the right ionic charge. So here you would think that it's Fe plus, but then the sulfate ion does not have the proper charge, and so you multiply those by 2. So now you have negative 2 and positive 2. And you can now simply name this iron 2 sulfate. All right, so the next one here is SnPO4. You can do the same thing, reverse the crisscross, knowing that PO4 is a single unit with a negative 3 charge, and so tin must have a positive 3 charge in this case. So this is tin 3 phosphate. And then the last one, since sulfate ion has a negative 2 charge, copper must have a positive 2 charge to neutralize the negative 2 from sulfate. So here we have copper 2 sulfate. All right, so I mentioned that sometimes polyatomic ions can have one less oxygen or one extra oxygen, and once that happens, the name changes, right? The suffix changes. So for example, for the nitrate ion, if you have one less oxygen, meaning NO2 minus, the name would change to nitrite. Yeah, so you would replace the suffix ATE with ITE. So let me show you here. Right, so these are all the other chemical formulas related to the previous one, only with one less oxygen. Right, so for example, you have NO3 minus, which is a nitrate ion, but when you subtract one oxygen from it and it becomes NO2 minus, the suffix ATE changes to ITE. So now we have a nitrite ion. Right, same thing with bromite, iodide, chlorite, sulfite, and phosphite ion. So yes, you would have to memorize these polyatomic ions. So the carbonate ion, CO3 minus, when you add a hydrogen, right, instead of subtracting one oxygen, you add a hydrogen to it, but instead of having a negative 2 charge, it would have a negative 1 charge. So this is called the hydrogen carbonate, or also known as bicarbonate. Now these polyatomic ions here can have one less oxygen further, or you can have one extra oxygen from the main polyatomic ions listed on the left. So let's look at an example here. For instance, the chlorate ion. Okay, the chlorate ion is, let's say the main ion here, has the chemical formula ClO3 minus. Okay, so if you have one extra oxygen, so instead of ClO3, you have ClO4 minus, right? So what you do is you add a prefix called per. Okay, so it would be a perchlorate ion. And you can do the same thing for the others here, right? Sulfate, for instance, SO4 2 minus. When you add one extra oxygen to it, it becomes SO5 2 minus, and you would call that persulfate ion. Same thing with phosphate. You can have a perphosphate, perchlorate, periodate, and so on and so forth. Now, from the chloride ion, right, one less oxygen from the chlorate, you have ClO2 minus. If you subtract one other oxygen from it, it becomes ClO minus. So in that case, you would add the prefix hypo. Okay, but it retains the name chloride. So it would be hypochlorite ion. Okay, so make sure that you know the names and chemical formulas of polyatomic ions. All right, so there are also what they call hydrated ionic compounds. So these are ionic compounds that contain water molecules, also known as the hydrates. All right, so here are a few examples. You have MgSO4 with 7 water molecules. You have CoCl2 with 6 water molecules. So naming these hydrated ionic compounds is actually pretty straightforward. The only thing you have to remember is the prefixes that indicate the number of H2O H2O molecules. Okay, so that would be hemi, mono, di, tri, tetra, penta, hexa, all the way to deca, right? So hemi is 1/2, mono is 1. That means you have a single atom or ion of that specific element, all the way to deca, which has 10, 10 ions for that specific element. So whenever you're naming the first one here, MgSO4, that would be magnesium sulfate. So you would name the ionic compound normally. So that would be magnesium sulfate. And since you have 7 water molecules, you would use the prefix hepta. So that would be magnesium sulfate heptahydrate. And you can do the same thing for the next one here. You have COCl2 with 6 water molecules. So that would be cobalt 2 chloride hexahydrate. All right, so let's take a look at these other examples here. You can pause the video if you like and see if you can try them for yourself. All right, so the first one here, we have calcium sulfate, all right, CaSO4, and because you have half of a water molecule, that would be hemihydrate, right? So we have calcium sulfate hemihydrate. For the second one, we have barium chloride hexahydrate. Third one here, we have copper 2 sulfate, because the sulfate ion has a -2 charge, so that must mean that the copper has a +2 charge. So that would be copper 2 sulfate tetrahydrate, because you have 4 water molecules. And the last one here is cobalt 2, so that tells you specifically that cobalt itself has a +2 charge, and then you have the phosphate ion, which is PO4 3-, right? It has a -3 charge. So you do the crisscross and you get CO3, PO4 in parentheses, and then 2 outside, with 8 water molecules, because it's a octahydrate. All right, so that is all for today, and I'll see you guys next time.